So the first one ends up being negative sine x. Second one ends up being sine squared theta. Third one is 2 cosecant theta minus 3 cosecant theta minus 6. Any questions about the first one? Good? Everybody understands the role of reciprocal identities. Cosecant is 1 over sine. That allows you to eliminate that. Everybody's good with the factoring on the end. Good? All right. So next, let's say the parts of the expression are different trig functions. So identify the identity that involves both or all trig functions in the expression. Use it to rewrite it with a single trig function. Use the methods previously discussed. So, cosecant squared x minus cotangent x minus 3. Number one, you never touch the one that isn't squared if there's another one that's squared in it. So you're always going to work with that one. Now, cosecant squared equals 1 plus cotangent squared. Cosecant squared equals 1 plus cotangent squared. So, I bring down 1 plus cotangent squared minus cotangent x, put the x there as well, minus 3. So I'm just using a Pythagorean identity. Make sense? So your first step is to show knowledge that you know what the Pythagorean identity is. All right, so now I'm going to collect like terms. Cotangent squared x minus cotangent x, and then negative 3 plus 1 is negative 2. Cotangent x factors into minus 2, cotangent x plus 1. And I factor. Good? Okay. Work on that one real quick. Secant squared x plus 3 tangent x plus 1 using a Pythagorean identity. First thing I do is I replace secant squared x with tangent squared x plus 1. Everybody good with that? Okay. So then the tangent squared x stays, the 3 tangent x stays, the 1 plus the 1 that's already there is 2. The two numbers that go into 2 that add up to 3 are obviously 2 and 1. So in either order you want, tangent x plus 2, tangent x plus 1. Good? Okay. Now, for probably the most important thing of today, moving forward to this whole unit. Hopefully you've heard the message of following instructions as this problem is saying to simplify sine t plus cotangent t cosine t. All right, what you're eventually going to realize is when all else fails, we're going to write everything in terms of sine and cosine. So in other words, secant is the inverse of cosine, so I can always write it as 1 over cosine. Cosecant is the inverse of sine, so I can always write that as 1 over sine. Tangent, with the quotient identities, can be rewritten as sine u over cosine u. And then cotangent u is cosine u over sine u. Okay? So, if I look at this expression, sine t plus cotangent t cosine t, there's no common factors. There's nothing squared. So now you go to plan C, which is write everything in terms of sine and cosine. So the sine t is going to stay exactly the same. The cotangent of t from the identity you just wrote down is cosine t, sine t, cosine t. So step 1 is showing knowledge, writing everything in terms of cosine and sine, and you're showing you know what those are equal to. All right. Step 2 is to simplify. Well, sine t is just going to stay as sine t for the time being. But if I take a cosine and multiply by cosine, I'm going to have cosine squared t over sine t. Good? Okay. Now, sine t is a denominator there. From last year in Algebra 2, rational expressions, I want to find a common denominator. So I'm going to take the first half and multiply by sine t over sine t. That way they have a common denominator. So that's where the skills you developed last year come in. Sine times sine is sine squared. So you're showing knowledge in that you're finding a common denominator. Once you have that common denominator, instead of writing it as 2 fractions, you can now write it as 1. So sine squared t plus cosine squared t over sine t. So again, I'm simplifying. Now, Pythagorean identities, showing knowledge. Sine squared plus cosine squared is 1. So 1 over sine t. And then reciprocal identities. 1 over the sine is the same thing as cosecant. So your final answer would be cosecant of t. Good? Flip it on the back. Simplify cosecant x minus cosine x cotangent x. Cosecant x is the same thing as what? 1 over sine x. Anything wrong with the cosine of x? Absolutely not. Cotangent x would be cosine x over sine x. So again, write everything in terms of sine and cosine. I'm going to leave this just like this for the time being. 1 over sine x. Cosine times cosine is cosine squared x over sine x. Do they now have a common denominator? You betcha. boy. Okay. We write it with the common denominator, 1 minus cosine squared x over sine x. Everybody good with that? Making sense? 1 minus cosine squared x from your Pythagorean identities is sine squared x. And then whenever I have something squared divided by itself, the last answer would be just plain old sine x. Good? That's the hardest thing to do in this unit. All right. Now, specific directions are the key. Rewrite 1 over 1 plus sine x so that it is not in fractional form. Okay, now what you have is 1 over 1 plus sine x. You have nothing squared. It's a binomial, all right? So you can't write it as 1 over 1 plus 1 over sine x. Please don't. It's not equivalent. All right, just like 1 over 2 plus 3 is not equal to 1/2 plus 1/3. Remember that. So instead, what we're going to do is multiply by the conjugate, which is the opposite expression. All right, so 1 over 1 plus sine x times 1 minus sine x over 1 minus sine x. All right, get some steps in today, a little bit of cardio. Whenever I multiply conjugates from last year and every other year you've done this, what happens to the outers and the inners when you do that multiplication? Cancel out. That's why we do it. So when I'm done, I'm going to have the expression 1 minus sine x. Everybody okay with that? Because multiplying by 1 stays the same over 1 minus sine squared x. So we're showing knowledge. We're multiplying by the conjugate. Now, Pythagorean identities, 1 minus sine squared is cosine x squared x. Now, this is the tricky part you got to remember. Our new denominator is now a monomial term. So you now write it as 1 over cosine squared x minus sine x over cosine squared x. And then this is the reciprocal identity. The reciprocal of cosine is secant, so that becomes secant squared x. Remember what our goal was? Simply to not write it as a fraction. And this is the part that's strange to people. That is probably not like something you've done before. Minus sine x over cosine x times 1 over cosine x. So that's what that becomes. So what I do is I break down the squared into the two parts. Got it? One of them is the trig function that's not squared, and the other one's just the 1. Everybody good with that? We just break it down. Not something we normally do. All right? So, sine x over cosine x from the previous page is tangent x. So that's just tangent x. 1 over cosine x is secant x. So my final answer would be secant squared x minus tangent x secant x. Now, do they both have a secant x in them? Yes. Can you factor it out? Certainly. But here's the thing about following directions. It simply said to rewrite it so that it's not in what? Fractional form. Is that no longer in fractional form in any way? So you're done. So make sure you follow directions. Now, you're not always going to distribute. I'll show you what I mean. And again, this is going to come with practice. Cosine squared u over 1 minus sine u. And multiply by the conjugate, which is 1 plus sine u. All right. Now, I'm not going to distribute that through yet. So I'm going to leave it as cosine squared u times 1 plus sine u over. Now remember, conjugates, outers, and inners cancel out. That's 1 minus sine squared u. So cosine squared u, 1 plus sine u over 1 minus sine squared u. This is why you don't distribute, and this is going to come with practice. 1 minus sine squared u is the same thing as cosine squared u. So it becomes cosine squared u over cosine squared u times 1 plus sine u. And then what are the cosine squared u's going to do to each other? Cancel out. And I got 1 plus sine u. For my final answer. Good? Any part of it troubling anybody? All right, now the last thing we're going to do. The last thing we're going to do is substituting. So it says, we write a function as a trigonometric function. Use the substitution, x equals 2 tangent theta, where 0 is less than theta is less than pi over 2, to rewrite 4 plus x squared underneath the square root symbol as a trigonometric function of theta. Okay, so square root of 4 plus x squared. Square root of 4 plus 2 tangent theta. Hold it. 4 plus 4 tangent squared theta. So I square the term, whatever it is. Ladies and gentlemen, in this class, these two numbers should always be exactly the same. All right, if not, we'll talk about that at a later date. But for the time being, these are going to be the same number, which would be 4. So if I factored that out, I would have the square root of 4 times 1 plus tangent squared theta. Everybody good with that? Everybody good from here to here and then there to there? They both have the 4s on it, so I pulled it out. Now the 4 is a perfect square. What's the square root of 4? 2. By Pythagorean identities, 1 plus tangent squared is secant squared. So this becomes 2 times the square root of secant squared theta. And then whenever I do the square root of something squared, what do they do to each other? Cancel out. I got 2 secant theta. So if you would, to end up today, do the one underneath it, please. 9 minus x squared. Your quiz on all this will be on Thursday. Short, like 5 questions. you end up at the end of the day with 3 cosine. All right. You replace the x squared with 3 sine theta squared. Again, you'll end up with numbers that are the same. You pull that out, then you use the Pythagorean identity to rewrite it as cosine squared, square root minus 3, square root of cosine. All right, like I said, today at 3 o'clock, if you haven't submitted it already, first homework of the marking period, 6 problems. The back of this is due tomorrow at midnight. The front of it will be on a video tomorrow and or a live stream. That's all we're doing tomorrow, Wednesday. We will go over that homework assignment if anybody has any questions. All right. If we get through that, because it is a half day, we will then start 5.2. Thursday at home, you'll take your quiz. It's short. And then Friday, we will finish.